Hey everyone, so today I'd like to talk about my project for Mod 3 for Flatiron. It's reuniting pets and owners with machine learning. So the data for this project came from the Austin Animal Center. It's the largest no-kill shelter in the US. They process about 18,000 animals every year. And this data set had 80,000 rows of data roughly. So each row of data was an animal outcome and the associated intake information for that animal. So for example, it might be a kitten that was taken in, it was 2 months old on intake. It would have, if it was healthy or not, if it had a name or not, and all sorts of data about this animal, and then the associated outcome, which is what we're trying to predict with this model. So I focused on the three top outcomes. They're return to owner, adoption, and transfer. So there's also euthanasia, disposal, missing, died, etc. But as this was a no-kill shelter, euthanasia is only in extreme circumstances, like when the animal is badly injured or sick. So it made sense to me, both logistically and morally, to just focus on return to owner, adopt, and transfer. So as we can see with cats, there's actually a strong seasonality with transfer and adoption, but not with return to owner. Whereas for dogs, it's pretty constant all year long. Also, quite a few more dogs get returned to the owner, as you can see with this green line, than with cats. Cats, it's really just kind of hovering around the bottom there. So anyway, I used several machine learning techniques to try to build the best model I could that would predict the animal's outcome based on their intake data. So the model that won was XGBoost. This is a strong machine learning algorithm that was developed recently. And it performed with over 80% accuracy on the testing data. And considering a random coin toss would be a 33% accurate model, considering it's a ternary classification test. With their three outcomes, 80% is really pretty strong. So this is a confusion matrix. It shows the percentage of correct classifications for each classification. So the first classification is return to owner. The second one is transfer, and the third is adoption. I focused on four major metrics after just general accuracy: return to owner precision, return to owner recall, adoption precision, and adoption recall. So precision refers to the ratio of correct classifications for that class compared to correct classifications plus false positives. So a low precision means that you're getting quite a few false positives, which is bad. Recall refers to correct classifications for that class divided by correct classifications plus false negatives. So out of the total true return to owners, how many are we identifying correctly? And then obviously the same for adoption and adoption recall. I didn't focus as much on transfers because that's more of a last resort. After an animal isn't returned to an owner or adopted, they may be transferred out to a foster home. So as we can see, return to owner precision is quite high at over 92%, meaning we don't have a lot of false positives. Return to owner recall is a little lower at 82%, but still that's pretty strong considering it's really the minority outcome, especially for cats. So this means that we can identify over 80% of cats and dogs that need to be returned to their owner, which can help quite a few animals. The same is true for adoption precision. There were a few more false positives, which leads to a lower precision score, but recall is quite high at 93%. So this model identifies 93% of animals that are going to be adopted in the future. So overall, this was a pretty strong model. It didn't perform so well on transfers, but that's just because it predicted that most of them would be adopted, which honestly isn't such a bad thing. So moving on with the insights, these are some of the features that went into the model that help us predict. So time and shelter, whether or not it has a name, age upon intake, these were all the most important features that can lead to whether an animal is adopted or transferred or returned to its owner. But also the intake condition, and how they're brought in. So are they a stray? Are they a public assist? Was it an owner surrender or even euthanasia request? Sometimes those, still get adopted. So these are all important features, and more importantly, these are all features that any reasonable animal shelter in the country or in the world would record. So this model could potentially be transferred to other shelters and used effectively as well. So to conclude, this model works pretty well. It's much, much better than a random coin toss. In fact, almost 3 times better. It can predict most animals that are going to be, like the vast majority of animals that are going to be adopted or returned to their owners. So with animals that need to be returned to their owners, I think we should use this model to identify them and feature them front and center on the animal shelter's website so that their families can find them as quickly as possible. It's also important to do that for pets that can be adopted as well. The sooner they get adopted, the better. Better, for the pets, for the families that adopt them, and for the shelter employees. It makes everyone's life easier. So we could do a little better to collect data. Location especially was pretty messy. Sometimes it was just the city of Austin. Sometimes it was a specific address. So in the future, collecting longitude and latitude data would help a lot. We could even create like a map showing where the animal was found or brought in, and that could help quite a bit too. There's no weight data. There's only vague health on intake data. So boosting that could help a lot too. So in the future, I'd love to build this into a web app that other shelters can use. I think that would help a lot. Additionally, I think we could probably make a better model by separating cats and dogs. But overall, I think just branching it out to other shelters would be my main priority. So I want to give thanks to Flatiron, the Austin Animal Center, and the wonderful cohort that's been supporting me this entire time. So please send any questions or comments to my email, and I will absolutely respond. As a little bonus, here is one of the decision trees from, I think it was the random forest model. So this just shows the complexity of the machine learning algorithm under the hood. I thought it was kind of fun to look at, though completely impractical, especially since we ended up using the XGBoost model anyway. But still, it's pretty fun to look at. Anyway, thanks for your time, and thanks for listening.